Hello, I'm Youngkyung from Department of Industrial Design, UIST, and today I'm going to present BodyPrinter, which is fabricating electric circuit directly on the skin at arbitrary location. This work was conducted with Neung, Myung, Andrea, Bianchi from Department of Industrial Design, UIST, and Artem Dementyev from MIT Media Lab. On-body electronics and sensors have been studied to augment the human with computing power. They were used to monitor humans' activity or status and also used as an interface. These were in form of a pre-made sticker made in 2D substrate and then applied to the human body. When these pre-made electronic patches are attached to the human body, the deformation in shape happens because of the curvature of the human body. In order to solve the issue, study using a 3D printer to fabricate circuit directly on the body have been conducted, but they could fabricate at only a limited location, such as back of the hand, because they use a box-type general 3D printer. So we present BodyPrinter. BodyPrinter is a compact wearable CNC plotter which is fabricating circuit directly on the skin at arbitrary locations. The hardware consists of a control interface, a wearable plotter, a control unit, and a power supply. The plotter has conductive-ink syringe and is operated by GRBA library. In the control interface, user can load a G-code file and adjust it quickly, and the G-axis calibration is conducted here to model the surface of the skin. Let's see how the prototype works. First, generating G-code. In this example, we used Fusion 360. Then loading a G-code file into the control interface. In this stage, we can adjust the circuit with mouse drawing and also set the ink amount. Next, calibration of G-axis by moving the tip of the extruder until it touches the skin. We can set the number of the calibration point based on the curvature of the skin. Next, fabrication process. After fabrication, we can add additional components such as a resistor, wire, and LEDs. After the ink dried, finally we can use the fabricated circuit as a sensor to monitor unbending. In the technical evaluation, first we printed on a flat sheet of paper 5 parallel lines with 5 extrusion rates and measured all 25 lines resistance based on the drying time. We found that the higher the extrusion rate, the lower the final resistance, but the longer it takes until it dries. So we set our basic extrusion rate as E/3, which has relatively fast drying time and low resistance. Second, we printed straight lines in different lengths from 10 to 70 mm on both paper and body. As a result, the resistance increases constantly as the length increases. With this result, we can estimate the resistance of the circuit we will fabricate. In the last evaluation, we printed 2 lines on 8 different body parts to explore the visibility. The data show that it is possible to print on surfaces with various curvature up to 0.1 to 1. In addition, we printed on various body parts and the slides show a total of 9 parts from head to feet. In the example application, we printed circuit can be used as a sensor to monitor arm movement and visualize the movement, and it also can monitor body posture. And finally, we made LED display on forehead. Although we work to make fabrication of circuit with BodyPrinter quick and easy to produce, our prototype still has several limitations. First, it mostly requires G-code input file and also semi-auto G-axis calibration. These time-consuming works will be improved by integrating proof pipeline and adding automatic calibration system with the camera. Second, characteristics of conductive ink change depending on the environment. Future work is needed to address these practical limitations. Finally, this paper mainly focuses on the technical feasibility of the prototype without conducting an evaluation with the user. The user experience through workshop will be needed to evaluate better. In conclusion, we presented the feasibility of the idea, several applications that shows the potential advantage of this prototyping method, and we believe that BodyPrinter could be applied for personal fabrication of electronics printed on the body with potential repercussion on fields such as health, HCI, and fashion. Thank you.